So after building the model, we're going to do different studies on the model. The first one is to find the displacement of the resonator as a function of position. What we have to do is to go to Model Builder, right-click on Study 1, choose Rename, and type Stationary. Click OK. Now right-click on Stationary and Compute. So we are now waiting for computation. What we want to do is to plot the y displacement of the structure after the computation is done. Now for the displacement, in the Model Builder, right-click on Displacement, choose Rename, and type Bias Displacement. Click OK. Go to the Model Builder again, expand the results, bias displacement. So expand the bias displacement. Go to the settings window for the surface. Find the expression section and type V. Click the plot button. Now click the zoom extents on the graphic toolbar. At this point, you have to compare your results with what is provided to you in Figure 2 of tasks. Now, we want to create a plot to show the electric potential contours in the gap. Go to Model Builder window, right-click on Results, and choose 2D Plot Group. Right-click on Results 2D Plot Group 3 and choose Contour. Now, in the settings window for contour, find the expression section and type V in the edit field. Now find the level section. In the total levels part, type 10. So change 20 to 10 here. Now click the plot button. Go to the Model Builder again, right-click 2D Plot Group 3 and rename it. So choose Rename. Rename it to Electric Potential Contours. Click OK. Now at this point, what we want to do is to create a view that shows the gap region only. So we want to zoom in the gap region. Again, we're going to Model Builder, right-click on Model 1 Definitions, and choose View. Now, go to the Settings window for View, and select the Lock Access checkbox. Again, go back to Model Builder, expand Model 1 Definitions, View 2. Then click Access. Now go to the Settings window for Access. Find the Access section. In X minimum, type -12. In X maximum, type 12. Y minimum, type -2. Y maximum, type 4. and click the Apply button. Now at this point you need to compare your results with that provided in figure 3 of your tasks. Now we are moving to task 2. What we want to do is finally to find the normal modes of a biased resonator. So first of all, open the existing stationary study. From the View menu, choose Model Library. Go to the Model Library window, and in the Model Library tree, select MEMS module, actuators, biased resonator 2D basic, and click Open. Now we are saving our file. What we want to do is to add an unbiased eigenfrequency study at this point. Again, we're going to the Model Builder, right-click the root node and choose Add Study. So we want to add another study. Go to Model Wizard, find Studies subsection, and select Preset Studies Eigenfrequency, and finish. Now for the eigenfrequency, we are going to the Model Builder again. Click Step 1 Eigenfrequency. And we're going to the Settings window for Eigenfrequency, finding the Study Settings section in the desired number of eigenfrequencies type 3. If we want to see, let's say, 4 different eigenfrequencies, we can type in 4. Now, what we are doing is to set up the solver to solve only for the solid mechanics variables. So going to the Model Builder window again, right-click on Study 2, and Show Default Solver. Now, expand the Solver 2 node and click on Dependent Variables 1. Go to the Settings window for the dependent variables and find the General section for the Defined by Study step list. Choose User Defined. Then go again to the Model Builder, and this time expand the Dependent Variables 1 node, as has been already done. Then you have to click on Mode 1.v. Now go to the settings for this field and locate the General section. What you have to do here is to clear Solve for this field checkbox and also clear the Store in Output checkbox. Now go back to Model Builder, click Dependent Variables 1, this time Mode 1.xy. Go to the settings for this field, and this time clear Solve for this field and Store in Output, both of them again. Go back to the Model Builder, right-click on Study 2, and choose Rename. Now you have to type unbiased eigenfrequency. And click OK. Now going to the settings for unbiased eigenfrequency, we locate the Study Settings section and clear the Generate Default Plots checkbox and click the Compute button. So right now. We want to see the results. So for plotting the data set, we have the data set. We want to set the data set to be in the material frame for post-processing. What we're doing is, again, in Model Builder, now expand the data sets. Click Solution 2 and go to the settings for the solution. After locating the solution section, from the frame list, choose Material X, Y, Z. Now we want to plot the mode shapes. So go to the Model Builder again, right click on Results this time, and choose 2D plot group. Now go to the settings for this group, 2D plot group, find the data section, and from the data set choose Solution 2. Now right click 2D plot group 4 and rename it. Change it to unbiased modes. Click OK. Now right click on the unbiased modes and choose surface. Go to the settings window for surface, find the expression section, and type V. Now right click on unbiased mode surface 1 and choose deformation. So just choose deformation here. Now go to the settings for this deformation, find the expression section. In the X component edit field, type U. That's already there. And in the Y component, V. That's already there as well. And then plot. Now we want to create a view to be able to see and visualize the modes. So the 3 modes that we were looking for. Again, we're going to Model Builder, and this time expanding Mode 1 node. Right click on Definitions and choose View. Go to the settings for View. Locate the View section as is seen here. Select the Lock Access checkbox. Go to the Model Builder, expand View 3 node. Click Access. Go to the settings for access, and in the X minimum type -25. In the X maximum type 25 and plot. Now you can see different modes. So we want to see 3 different modes in this case, and we need to compare the mode shapes with what is shown in figure 4 of the tasks for all the modes computed. So we have the unbiased modes here. We can change the eigenfrequency to see different modes. So here, as you can see, we have 3 different. So if you're changing to 2.2 and plotting again, we can see the second harmonic and also the third harmonic by changing the eigenfrequency to 4.3. The task part is done. Good luck.